Hello everyone, welcome back to the channel. Today we are diving with the topic SVM, Sport Vector Machine Learning Algorithm. This is the most popular algorithm and this is the most beneficial algorithm in machine learning. And many interview questions come on this too. This is a big concept. So today I am going to just make you understand the big picture or the basic intuition behind the SVM. This is used for classification and regression both. Okay, and this video is going to be perfect for everyone, either you are a beginner, intermediate, or advanced or professional level. This video is going to be beneficial for you. Okay, so let me open the whiteboard. I will also give you the small practical example too, how it look like the SVM, okay, using Python. But in upcoming videos definitely we will work with the real time data set too. Okay, but first your goal is to understand what is SVM, why we use it. Okay, all right. So here the very first thing is SVM is a supervised machine learning algorithm. Okay, this come under the supervised machine learning. Okay, sport vector machine. Okay, we call it SVM. Okay, and this is used for classification and regression, okay, for both type of the problems. Okay, in classification we call it SVC, sport vector classifier, SVR, sport vector regression, and these both libraries come from the package SVM. Okay, like this. So when you implement it using Python, you will import this package and this library according to your problem. Okay, if you are doing the classification, then you will import this one, otherwise you will import SVR. Okay, and today you are going to understand the terms which is very popular in this, that is your hyperplane, margin, sport vector, linear separable, non-linear separable, and kernel. Okay, so this margin and kernel is itself a big topic, so I will make a separate video on these two. Okay, so but let's understand about these terms and what is SVM. SVM, as I told you, it is used for both problems, but mostly we use it for classification. Okay, so now let's start with the basic terms. Okay, so we will draw a line here first. Okay, and we will move ahead. So let's say you have a one data set. So you want to predict the here two classes. I am giving the name it, you can say we can name it simple class. Okay, there is a one this positive class and there is a one negative class. Okay, so this is based on the, you can say, size and weight. Okay, so it can be any value here. So based on these given features, you are predicting whether it is a positive class or negative class. Okay, now you want to classify it using SVM instead of using logistic regression. I will also make you clear, give you the clear vision why we should use it above the over the logistic regression as well. But first, let's understand what is SVM. So what do you do? In general, this is the logistic regression, right? So this is x-axis, this is y-axis, right? So you can also assume it, this is your x1, this feature, here is your weight, right? And here is the size. And based on that, you are classifying the classes. These are your positive classes, right? And this is negative class. Okay. Now, when you want to classify them, you want to separate them, you will draw one line between it. Okay, like this. This is you do using your logistic regression tool. Now, how the SVM is different from it? It is also separating it, right? The logistic regression is also separating. But what is the different major difference between SVM and your logistic regression? In SVM, this is a 2D data, right? We call it simple line. Okay, but in SVM we call it plane 2. Okay, so we will draw a one parallel plane with this line like this. Okay, and this is called hyperplane. This is called hyperplane. Okay, combined this one, this is the plane. Okay, you are drawing the plane parallel to the this line. Okay, now in technical term in SVM we call it hyperplane. But now here I will tell you one more thing. Sometime during the interview they will ask you what is the difference between line, plane and hyperplane in SVM. Okay, so line is you are using, which is this one. This is for your 2D data actually. Okay, this is when we have a 2D data, you separate it like this, right? This is a line. Okay, and when you are trying drawing this plane corresponding to this one, this is called plane. Okay, this also come up in the 3D data too. It is also going to be always there. Okay, and this is called plane. But combine these two when your data is very in a high dimension, maybe 4D, 5D and more, that is called hyperplane. Okay, that look like something this. So let me here draw this one. Okay, so you have a one another, this is your x1, x2, x3, x4. So when you separate the classes in this, right, you will draw like this. Separate the data like this. So this is a hyperplane actually. Okay. This is I am just explaining you at a more deeper level. I will definitely show you in the nonlinear form too. But this is just the diagram. Here can be the data points. Here can be the your this one cross cross, and below this line it can be below this hyperplane there can be the negative data points. Okay. Okay, now come back to this diagram. Okay, so here you can see this is a line, this is a plane. You are drawing parallel to the this line. This is called hyperplane too. Okay, and now the distance, this one, the data points which is coming above this line, this is called positive distance. Okay, we can name it positive D1, or you can name if you have another class, then you can rename it with that one. The data points which is below this line, this is the negative distance. Okay, this is the negative distance, and this is in total called margin. Okay, this is called margin. And now what is the distance? Distance from your this line to the this data point, and the from this positive distance is from this line to your these data points. Okay, now did you notice there are some data points which lie on the line here? This is the negative one lie on here, and the data points which lie on the plane, right, that is called support vector. Okay, this is called support vector, and this is margin, and this is distance. So this is the most important term. You should have the clear vision about it, right? What is a hyperplane? What is margin? What is a positive, negative distance, right? And what is a support vector? Okay. Now we will talk about what is the goal of SVM here. Okay. Why you are using it? What is the main goal of the your SVM? The main goal of the your SVM is to create the more generalized model actually for the future data. More generalized model for future data. What does it mean? Look at this. You in simple normal like the logistic regression, you just draw this line, right? Tomorrow in the new data set, right? You might have the data points which lie here too, right? It is going to be close to this one, or it might come to cross this one too. So this is going to be misclassified, right? And the model accuracy is going to reduce. But in the SVM, it has a distance actually between the your this line and the this your data points too, which is like a drawn, we call it plane, right? This is totally called hyperplane. So this is making a distance. In future data set, in future data or test data, even if you have the data points here, it will still be classified clearly, right? Because it has a distance, it has a space, right? Between this one. That's why this is very, very popular. This is the goal of your, like the SVM, to create more generalized model for the future data. That's why it become more generalized model. Even in the future data set, you have the more data points, which is a very high value or close to this one. It will try to cover up. Okay. It will always try to cover up. And that's why this is robust to outliers. This is another advantage. Okay. This is robust to outliers too, because it is a classifying even if the data point is here, right? It has classified very clearly by drawing this plane, right? So this is belong to negative class and this is belong to positive class, right? And that's why this is popular. This will become the more generalized model and robust to the outliers, which is not in the case of your simple logistic regression model or other one. Okay. So it reduce the overfitting too. Reduce overfitting. Okay. This is another advantage. Okay. So now this is just the basic term. Now you understood what is distance, what is positive distance, what is negative distance, what is hyperplane, what is margin, what is a support vector. Now I will make you understand how it select the correct hyperplane, right? So we will draw here two cases, okay? So this is a case one, and this is the case two. So let's say you have the data points here positive. We can take it here cross, okay? Same we can take on this side. And this is cross. Okay. Now, when you are applying the here, you are separating them, you can draw the line like this way, right? Or might be you can draw the line this way too. Okay. And if you want to make a third case, we can choose a different color from here, this blue one. You might choose this one. This is the third case, right? It depends, right? So we can name it with the here. Let's say we can name it with the line 1. This is line 2. This is line 3. Okay, I'm just renaming it. You can name it with anyone, pi or whatever you like. Okay, now this is the duty of SVM. Okay, which case it will select. Okay, and how. Okay, now we will draw the plane parallel to this line. Look at this one. So I will choose the different color now. So let's draw it like this, okay? So it will SVM draw this line, okay, parallel to this one. This is your hyperplane, right? And here we will pick up only one case. Okay, so I am going to delete it like this. Okay, now here it will draw the line like this. Let's say plane this one. Okay, now this is the responsibility of the SVM. Goal of the SVM to create the more generalized model. It can be the more than two lines, as I have showed you the three cases. It can be more than that. But now it's a duty of SVM to choose the best hyperplane. On what basis it will decide? This is your positive distance, D1. This is negative, right? So these data points are the below the line, below the hyperplane, all the data points are negative, and this is the positive, right? So the goal of the SVM is to choose the hyperplane which has the shortest distance between positive to negative data points. Okay, the shortest distance of this one. This is the number one, like the goal. Select the shortest distance between positive and negative data points. Okay, and it will also take care about this distance. Okay, that is your support vector, right? Its second goal is to maximize the distance between the between the data points, sorry, between the data points and line. Okay, so there is just a small difference. Okay, students sometimes get confused between it. This distance should be shortest, but this distance can be larger. The positive to negative distance should be short, but it will also, its a second goal is to maximize the distance between your positive data points to this line too. Or you can say the support vector distance between the line and these data points too. Same with on the negative side. Okay, so this is the goal of the your SVM. And here if you look at this, here is the distance can be shortest, but in this case the distance between the line and the your this one, right? We can take it D1 positive, this one, this is negative, D2. Here distance is very short because it is like covering many data points as coming between your line and the this plane too. Okay, so this is a short distance. So your SVM will never choose this hyperplane. It will choose the hyperplane where there is a large distance between your these like the data points and this line. Okay. So that's why this is the goal of SVM. So that's why this is very popular and it is able to handle the outliers, robust to outliers, and also the more generalized model. This is the biggest advantage. So this is the correct case. This is a hyperplane will not be selected. Okay. Now I will tell you one more thing here. Let me change here color. Okay. I hope it makes sense to you. What is the goal, right? This is the goal. And here I will show you one more thing. So let me draw one more diagram. Here is the positive data points. Okay. And this is cross. Okay, so this is the line. Now you might be thinking, I have talked about the which hyperplane it will choose, what are the hyperplane margin and other things, right? But I did not tell you so far how it is going to draw this plane, right? We did not talk about yet how it is drawing this plane, right? Parallel to this line. Okay, I will tell you. The SVM will try to draw this hyperplane So we can choose this color. This will try to choose the plane which cover minimum the one data point from the positive and one data point from the negative. This is a way how it will draw the plane parallel to this line. Okay, that's why this is going to reject this one. Okay, this case, because there was a short distance, it cover up the many data points inside this. Then what will happen in future, if in your data set you have a more data points, then if you are your SVM, if you are going to choose to this hyperplane, what will happen in future, you might have the data points which come more near to this one and it will come here. So it will be come jump on the other side of the this one. So this is misclassification. That's why whenever you are SVM choose or draw the this your plane with this parallel line, it will only draw the line where it touches the first your data point from the negative class and the positive, right? Support vector. These are support vector. It is not going to never choose or draw the plane. In case it draw it, it is not going to choose this one. Okay. So this is the way how the SVM draw the this plane parallel to this line. Okay. How to draw plane parallel to the line. Okay, so it should touch the one data like the data points. Okay, this is called support vector. That's why this is very popular. That's why its name is a support vector, because it matters a lot. It should touch the first data point, which is all these are like the support vector which come on this line. Okay, this is most important concept actually. You should now till so far you have understood about the basic terms. What is a hyperplane? What is margin? What is positive, negative? What is the goal of SVM, right? And how it draw the plane parallel to the line. Okay. Now we will move ahead. Okay, with the one more term. So let me change the color. Okay. Till so far we have discussed this one. Okay. So this, I'm just drawing the another example. So this is a easy for you, right? You are drawing the plane like this. Okay. This is easy because this is just the 2D data, right? It is easy to separate. Okay. So we call it linear separable. Easy to separate, right? But there might be your data in this form. Let's say like this. And here is a positive points. Or we can draw it with a different color. So it is like this. Right? Now you cannot draw the line like this, right? It's hard to you separate them. Okay? And this term is known as non-linear separable. This is a non-linear data. Okay? Now it is not separable. We did not separate it yet, but we will do. Here we go. So if you want to separate this one, okay? So I will remove this one because we need to separate them. When you apply the SVM on this, here is a one term you use kernel. Okay. So it is further divided into your RBF. This is your basic one RBF method. This is you have a sigmoid. And you have another method too. RBF is your radial basic function. Okay. And we have the third one. This is a sigmoid. This is RBF. The third one is your polynomial. These all three methods used for nonlinear separable. Okay, when you apply the like kernel, it will convert your this data, even it is in the 2D form, right? It is going to be converted into 3D like this. Okay, and your data points might be like this. So this is your this one, and we can make it here the plus. Okay, and it will draw the hyperplane like this. Okay, so we can make a little distance. This is very close. So let's say here some data points. Okay, and it will draw the line like this, and this is a plane. Okay, and it will generate the like the plane this one. So this is your negative distance, and this is positive distance, and this is margin. Okay, and this is your hyperplane. Okay, and this is distance. It will do like this. Then practically you won't be able to see like this, but when you draw it, it will look like this, like this. Okay, so it will like can separate your data points like this. All data points might be lie in this portion too. Then it will draw the this case, let's say like this. So if you have this one, here is your another class, the green one, right? Then it will draw the hyperplane here, something like that. Okay, so this is a position. It can be. It depend upon the like a 2D, 3D, or maybe more than that. Basically, it is used with the kernel parameter actually. Okay, it will convert your first 2D data into 3D or more than that, 4D, 5D. Okay, and then separate it. This is the role of kernel. Okay, but definitely I will explain it in a detail. Okay, but I just wanted to give you the overview what is a linear separable and non-linear separable. Okay, now I will give you the just at the end the recap. Okay, before we jump on to the practical example. So this is just the recap. Okay, again this is the one. Okay, so this is your data points. This is, we can take it cross. What is this? Just drop a comment now. You drop a comment. What is this? Okay. And what is this? What I'm drawing right now. Okay. And this is positive. This is negative. This is D2. This is D1. And this is called margin. This is called distance. This is the distance between the your negative data points or support vector to this line, and this is the distance between positive data points to this line, and this is totaling called margin, and this is complete this picture, right? This is plane, and this is line. Okay, and completely this is also known as hyperplane. Okay, and this is support vector. Okay, so you have learned what is SVM. You can drop a comment now, write it in your own words. What is SVM? And what is a support vector? Third, what is margin? and what is the goal of SVM? Okay, so now I hope it makes sense to you right now. Okay, what is the major difference between your logistic regression and SVM? Why we use the logistic regression over the, sorry, why we should use SVM over the logistic regression, right? In logistic regression, you only have this line to separate. If any data point come here, it won't be able to handle it and misclassify it. That's why it is not able to make a more generalized model. But your SVM will help you to create the more generalized model, less overfitting, and it also able to handle the outliers too, robust to outliers. Okay. Okay. So now this was the just big picture about the SVM. Okay. Now we will move ahead with the practical example. Let me share my screen. Here we go. All right. So here I have created the dummy synthetic data for the classification. For that, I'm using the library make underscore classification. Here is the SVM. I told you we import the package from the sklearn, and then if you are using the your classification problem, you need to import SVC library. This is the way how you import. And then matplot and dumpy. Here we are creating the linear separable data set. Using the make classification method, it will generate the two classes synthetic data with the number of sample 100, number of feature 2. Redundant is equals to 0 means, sorry, the features which is used for the linear relationship. Okay, so here it is count is 0. Information is nothing, just the information about your classes. Okay, and this is the clusters, and class separation to random state is this one. Here we are just to train the linear model. We will create the instance of the model SVC. Kernel is equals to linear, right? Because this is not a non-linear. So you will mention kernel is equals to linear. We don't need to convert it into any, because this is already the only two features 2D. Okay. And fit on to the XY. Here this function we are making to draw this diagram. Right? I showed you this diagram on the whiteboard, right? It will look like this. So you have a two classes balls, red and blue, and it is going to separate them, right? Now look at this. So what it does, it will plot the figure first, GCA on the x-axis and the y-axis. This is for your x-axis data points and y-axis. And then it is doing the x-axis, y, create a grid, evaluate the model using the mesh grid. It will just check the grids created based on this line space on the x-axis and y-axis. And then model decision function. So what this function, this is the evaluate the dish for the samples in X. Okay. So it will take, you can see here, it is explaining you. Okay. It will take the number of samples or the features. We have only two features. Okay. And then it will return the this. Okay. Here, this is a more like the result about it. Okay. It is a inbuilt method. So it is taking here npc underscore xx revel. Revel is nothing. This is just a flat your 2D dimension data on the x-axis or y-axis, and then just reshape a contour. This is we are using to draw these three lines, your hyperplane. So this is the line, this is the plane, you are parallel drawing it, and the data points which is coming on this one, this is called support vector, right? This is a hyperplane, and in short it is a plane, this is the line. Okay, and this is the distance, this is the distance between your, you can consider the red here above the line, this is positive and this is negative. Okay, so this distance should be maximum, but the total distance between the positive and negative data points should be short. This is the goal of SVM. Okay, and then it is drawing like this. So this is just a sample of your 2D. Okay, this is just the sample of 2D. We will definitely sense to you. Now the one question from my side, drop a comment. What is the goal of SVM? Second question, why you should use the SVM over the logistic regression? Okay, so these two questions, just answer it. Okay, and I would really appreciate if you are commenting on the video, and if you want me to make any video on any topic, just feel free to drop a comment. Okay, and thank you so much for watching this video, and keep watching this series because this is very important algorithm. Okay, thank you.